divide and conquer examples. So we just saw basic examples where like range sum increased by 1 each time. List sum, the list grew 1 smaller each time. Power, the exponent decreased by 1 each time. And interleave, each list changed in size by 1 each time. There are other ways to recurse. And later on, we're going to learn more interesting divide and conquer kind of algorithms. Here, the basic idea we're going to use, though, is do something to the left half and do something to the right half, and then combine those. And that's sort of setting the stage for when we start looking at more interesting algorithms that do this. I'm thinking things like merge sort and quick sort and so forth. But for now, let's just say if we're going to add up a sum of numbers over a range. This is exactly the same range sum as this one, but solved differently. In this case, we're going to say, hey, to add the numbers from 10 to 15, find the middle number. 10 plus 15 over 2 is, the middle number is 12. So it's going to be 12 or 13. Here it's 12, right? Okay, so now what we're saying is the sum from 10 to 15 is the sum from 10 to 12 plus the sum from 13 to 15, splitting it in left half and right half. Now, you might wonder, how is this going to work? How does it end? Well, think about the sum from 10 to 12. The middle is 11, so that's the sum from 10 to 11 plus the sum from 11 to 12. Now, think about the sum from 10 to 11. The middle is going to be 10 plus 11 over 2, which is 10. And you get the sum from 10 to 10 plus the sum from 11 to 11. Well, what is the sum from 10 to 10? We no longer need to recurse because the sum from 10 to 10 is simply 10. And that's how this works. It keeps breaking down each range into a left half and a right half, and smaller halves until you get to a singleton range, at which point you're done, it's just the value. And this actually works beautifully fine. Very, very cool stuff. We can apply the exact same principle to a list. To take the list sum, you take a list sum of the left half and you add it into the list sum of the right half. Now here we have two terminating conditions. We can actually wind up with a singleton, or depending on the size of the list, you can wind up with an empty list, in which case the sum is simply 0. Power is going to work the same way again. Well, no, it's not. It's going to work similarly. So with power, what we say is like 2 to the 5th equals, hang on a minute. Let's think about 2 to the 4th. No, actually, let's think about 2 to the 8th. 2 to the 8th is 2 to the 4th quantity squared. So 2 to the 16th is 2 to the 8th quantity squared. So if you divide your exponent in half, you can square the result of that, of like 2 to that power, and this will give you the same answer. This works when your exponent is even. When it's odd, what we'll do is we'll do the even case that's 1 smaller, and then multiplied by 1 more base. In other words, 2 to the 5th is 2 times 2 to the 4th, but 2 to the 4th is 2 squared, quantity squared. And so in this way, what's really cool, let's say we're going to do 2 to the 20th. 2 to the 20th is 2 to the 10th squared. 2 to the 10th is 2 to the 5th squared. And so what's happening is we're very quickly logarithmically approaching 1 or 0, which are 0 is our base case here. And once again, we can see that this actually works, and works very well. Interleave, once again, same idea of splitting lists in the middle, and you can do this instead of splitting lists, going just one at a time. So what do we got going on here for interleave? List 1 up to the middle. Right, so what you do is you interleave the right half of the lists, and then you add on to that the interleaving of the left half of the lists. And this will have the desired effect, which when we run, we go ahead and we see 1, 4, 2, 5, 3, 6. Very nice. So those are divide and conquer examples. These examples are not the most compelling. They're not bad, but later on when we do other algorithms similar to this, but we'll see that we have enormous savings at times, and we can we can solve problems in different function families because of divide and conquer, going, for instance, from quadratic to n log n, which is a big savings.